everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class, and that has been the class is your the 17th class of the session. In last classes we had done your 16 classes of CBNST, which has been the computer based numerical and statistical techniques. In that we had even though started with unit 1. In last 16 class we are dealing with unit 1 only. That has been the name of the unit as your computer arithmetic errors and rules of equation. In that we had done your second method, dissection method, neutral absent method, and many more we had done. Of course we had found out for the determination of the Jacobian in the last classes. So today we will go ahead for the iteration that will use the Newton-Raphson method for the two variables only in this class. So first of all, before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So the first question of the session is here. Obtain the roots of the following system of equation using Newton-Raphson method for two variables that is fx comma y equals to x squared plus xy minus 10 is equals to 0, and gx comma y equals to y plus 3xy squared minus 57 is equals to 0. You have to solve up to first iteration only, that take x0 is equals to 1.5 and y0 is equals to 3.5. Now we find out the solution here, which is fx0 y0 equals to 1.5 per square plus 1.5 into 3.5 minus 10, that is equals to minus 2.5. Now for gx0 y0, we'll put the value that is been 3.5 plus 3 1.5 and 3.5 square minus 57, which is equals to 1.625. Differentiation of x comma y upon dx is equals to 2x plus y, which is hence fx0 y0 upon dx is equals to 2 in 1.5 plus 3.5 minus, that is being equals to 6.5. Now for df x comma y upon y df dy, for that it is equals to x, so hence df x comma y comma upon d comma d of y is equals to 1.5. Now for the next, d of gx comma y upon dx is equals to 3y square, hence d of gx naught y naught upon dx is equals to 3.5 square equals to 36.75. dg of x comma y upon dy equals to 1 plus 6xy, hence comma upon d of y that is equals to 1 plus 6 1.5 3.5 that is equals to 30 32.5. So we go ahead for the same, that the determinants of Jacobians that can be calculated of Jacobian can be calculated as follows. For that, comma g is equals to df x naught y naught upon dx x naught y naught upon dy d of g x comma y comma upon dx dg x naught y naught upon dy that is equals to 6.5 1.5 36.75 and 32.5. that what we had find it out. We'll do it. 6.5 into this and multiply with this. 32.5 minus 1.5 multiply 36.75 will get 156.125 that we get here while solving this determination here. Now we go ahead further, which we'll talk about it. So putting the values in the equations that we had made it up. So we go ahead for the same. Putting values. So when that is in x1 is equals to 1.15 minus 2.5 1.625 1.5 and 32.5 whole upon 156.125 which is being equals to 2.03603. For y1 it is equals to 3.5 plus minus 2.5 1.625 upon that is in 6.5 36.75 all upon is 156.125 equals to 2.84388 that we get. So these are the values of roots after frustration. These are the values of roots after first iteration. So now we talk about iterative or successive approximation method, and that has been important, of course. That has been iterative or successive approximation method. So for that it will be having, and for iterative or fixed point iteration method also they had known as, and just I write it down, or fixed point iteration method, fixed point iteration method as well. So that the function f(x) has been expressed as x is equals to, and then the fixed point for the formula is to be given here, xn plus 1 is equals to xn here, and for that initial approximation x naught which is must be selected in the interval a comma b, is that root lies. And for better conversions we can say that it will be dash x is less than 1 in the interval of a comma b. Now we go ahead to solve it out the questions here, so that we can get the clearance about it, and we can even do use these questions by using the iterative or a fixed point iterative method here. We go ahead with the questions here, so that we'll solve it out iterative and successive approximation method, which is of fixed point iteration method. And of course we go ahead here. The question we have, find the root f x equals to 1 plus 0.3 cos x by iteration method that shows results of 6 iterations. We have to find out the results for 6 iterations. Okay, so no worry about it, we do that. Here we take equals to 1 plus 0.3 cos x and phi dash x is equals to d of dx, which is equals to phi of x, that is equals to minus 0.3 sine x here. So for the same, with this, that maximum value of sine function, maximum value of sine function is plus minus 1. Why that has been phi dash x is less than 1, so that the equation we have x equals to 1 plus 0.3 cos x and fx is equals to x minus 1 minus 0.3 cos x, which is equals to 0. To establish an interval in which the root lies as f0 is equals to 0 minus 1 minus 0.3 cos 0, which is equals to minus 1.3. So f pi by 2 equals to pi by 2 minus 1 minus 0.3 cos pi by 2. So here pi by 2 in a radians, which has been equals to 0.5707963. So f0 and f pi by 2 is is less than 0. So root lies in 0 comma pi by 2. So here we can take the initial approximation as 0 or pi by 2. So let's take x0 is equals to pi by 2, which is equals to 1.5707963. And so we can now apply the successive iteration. It can be given as, which has been xn plus 1 equals to phi xn, that is of phi xn is equals to 1 plus 0.3 cos x here. For iteration 1 we go ahead, and that what we'll have to talk about it. So yes, we go ahead. Iteration 1, for that it will be x1 is equals to phi x0, and that is being minus equals to 1 plus 0.3 cos x0 and equals to 1 plus 0.3 cos value 1.570796C, that has been equals to 1. Now we go ahead further for iteration 2, and that is we have so for iteration 2 it will be x2 is equals to phi x1 equals to 1 plus 0.3 cos x1, and that is equals to 1 plus 0.3 cos 1, which is equals to 1.1620906. We go ahead for iteration 3. So for iteration 3 it will be x3 is equals to phi x2 equals to 1 plus 0.3 cos x2, that is equals to 1 plus 0.3 cos 1.620906, which is equals to 1.119225. Now we go ahead for iteration 4. For iteration 4 it will be x4 is equals to phi x3 minus equals to 1 plus 0.3 cos x3, and that is being equals to, we'll put the value 1 plus 0.3 cos 1.119225, and that is the value we'll get here is 1.13091353. Now we go ahead for iteration 5. For iteration 5 it will be your x5 is equals to phi x4 equals to 1 plus 0.3 cos x4, that is we put the value 1 plus 0.3 cos 1.3031314535. For the same we'll get your value here, and that has been equals to 1.12775. Now we go ahead for iteration 6. So for iteration 6 it has been equals to x6 equals to phi x5 equals to 1 plus 0.3 cos x5 equals to 1 plus 0.3 cos 1.12775, and we'll get the value 1.128608808. For the next we have iteration 7. Now for the iteration 7 here, as your x7 is equals to phi of x6, that has been equals to 1 plus 0.3 cos x6. We'll put the value which is 1 plus 0.3 cos 1.128608808, and we'll get the value as 1.128375476 here, that we get the value here. Now we will go ahead for iteration 8 as well, and that's what we going to have to talk about it. So yes, we'll do it, and for iteration 9 as well we'll find it out. So for iteration 8, so for iteration 8 it will be x8 is equals to phi x7 is equals to 1 plus 0.3 cos x7, and we'll put the value 1 plus 0.3 cos 1.128374, and we'll get the value here 1.12843854. So we'll go ahead for iteration 9, and that is being, so iteration 9 will be, that is being x9 is equals to 5, x8 equals to 1 plus 0.3 cos x8, and we'll put the value 1 plus 0.3 cos 1.12843854. It will give you the answer 1.1284214 here. So here the value of x8 and x9 are repeat up to 4 significant digits of the points, and hence approximate value of the root is 1.128421444. That is correct up to 4 decimal point. We'll go ahead for the next question, that is being important one, and that we have as follows. Is your another question, and the question is, solve the equation x square plus 2x minus 6 is equals to 0 using simple iterative use 5 iterations. इसमें हमें 5 iterations use करने हैं. So we'll do the same here. So if we can rearrange this equation, that is being x is equals to 6 by x minus 2, on root of this equation that lies near minus 4. So for that it will be your 5 dash x equals to minus 6 upon x square, and mod of phi x naught, that is being less than 1, at x is equals to x naught, which is equal to 6 upon 16. So this is the method that will coverage. Let us apply the upper iteration method, and that the formula for the same we have is your xn plus 1 is equals to phi xn. That is being the formula. So we go ahead for iteration 1. So iteration 1 we have here. So for that it will be x1 is equals to phi x0 equals to 6 upon x0 minus 2 equals to 6 upon minus 4 minus 2, which is equals to minus 3.5. that we have for iteration 1. We go ahead for iteration 2 as well. For iteration 2 it will be x2 is equals to phi x1 equals to 6 upon x1 minus 2 equals to 6 upon minus 3.5 minus 2, which is equals to minus 3.71428571. For iteration 3 we go ahead. That is, we have to go ahead. So for iteration 3 it is your x2 equals to phi x2, that is being your 6 upon x2 minus 2, which is equals to 6 upon minus 3.71428571 minus 2, that is being equals to here is minus 3.6153846115. For iteration of 4 we go ahead. For iteration 4 it will be x4 is equals to phi of x3 minus 6 upon x3 minus 2 is equals to 6 upon that is being minus 3.6153846115 minus 2, which will give minus 3.6595744468 here. Now we go ahead for last iteration, that has been the iteration 5. and that has been we have. For that it will be x5 is equals to 5 of x4, and that is being equals to 6 upon x4 minus 2, which is equals to 6 upon x4 is minus 3.659574468 minus 2, and that is will get your value here is your minus 3.6395349 that we get here. And now here we're gonna end up with this as well, and so that will continue with the next coming classes, which is of course being important one, and that what we even do have to go ahead as well. So in the respective talking about questions, if I'm going ahead, yes, we had done your 57th questions in the last in till this classes. So we'll continue with the 18th class of the session of CBNST in the next coming class, where we're gonna start with your 58 question of the sessions here. So that is being important you all, and if you had not visited the last videos, you can just go ahead through the playlist we had made it that you will get all the videos there which we had uploaded lastly. So on the same cases other than CBNST, yes, we had done your sociology and software engineering, we had done your chemistry, in that we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7 and unit 8, unit 9 with their conversions, logarithm, atomic mass with their molar masses as well. After talking about that, yes, we had done your which has been the ER diagram we are dealing with. We are dealing with English vocabulary, which is enhance your English, and of course we are dealing with we had done your reasoning, and that we had done your verbal reasoning, which has been including the general mental ability and the logic reasoning. In non-verbal reasoning, we had done your series, analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice and dot situation as well. And we are dealing with quantitative aptitude, in that there has been two section which has been arithmetical ability and the data interpretation. In arithmetical ability, we had done where we had started with we had done operations on numbers, SCF and LCF of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, sums and indices, percentage, and now we are dealing with 11th topic, that has been the profit and loss here. After talking about coming towards CBNST, which has been the computer-based numerical and statistical technique, in that we had started with unit 1, and in that computer arithmetic errors, that has been we had done floating point arithmetic, machine lexicon, round of errors, chopping error, truncation error, associative and distributive law of the floating point arithmetic, inherent error, error propagation, numerical instability. In roots of equation, we had done second method, Newton-Raphson method, and a fixed point iteration method for simple root and derivations of the root of the conversions, attic and accelerations of conversions, modified Newton-Raphson method in a multiple root, Bridge-White method for polynomial, and Bystov method for the quadratic factor, that computer algorithm of these methods as well. In terms of unit 2, after completing unit 1, we'll start discussing about unit 2. In that we have to discuss about interpolation and curve fitting. In interpolation, we have to cover up the algorithm and the error analysis of Lagrange and the Newton divide and differences interpolation, relationship and the various differences operators, piecewise linear interpolations, cubic spline interpolation, natural spline, Chebyshev's polynomial approximations, Langkos economizations of the power series. In curve fitting, we have to cover up the linear and the non-linear least square approximation, that is your conditioning at least squares methods, gram schematics process of the orthogonizations, computer that is your that algorithm at compute algorithm at least the square curve fitting. In terms of unit 3, we have to discuss the differentiation and integration. In that we have to cover up the method based on the interpolations and the finite differences, the charts and extrapolation, error analysis of the trapezoidal and the Simpson method, Newton's integration method, Gaussian's integration method, Gauss-Lagrange method, Lobato integration method, and Radau integration method, terms of the integration method as well. In terms of unit 4, we have to cover up the solutions of simultaneous linear algebraic equation. In that we have to cover up the Gauss elimination method, the conditional system, condition numbers, successive and our relaxing matter rate of the convergence. In solutions of the ordinary differential equation, we have to cover up the single step method, Runge-Kutta method, second order, third order, fourth order method, and multiple step method with a predictive corrective method as well. In terms of statistical technique, we have to cover the statistical hypothesis, test of hypothesis, type 1 and type 2 errors, level of significance test involving the normal distributions. Yeah, so here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many me and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.